Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 6, Dilations on the Coordinate Plane. Okay, so we begin this lesson with exercises. Classwork exercise, there are 5 questions on this page here. So please pause this video, see if you can do them on your own from the information given in last class. And when you are ready, unpause the video and we'll check the answers. Okay, here we go. So exercise 1 through 5, point A is at 7, 9, and it's dilated from the origin by a scale factor of r equals 6. That means that the numbers are going to get larger or further from the origin. So when that occurs, this is going to get further, so the numbers will get larger because r is greater than 1. It's asking what the coordinates of point A are. So you know how I am with my formulas. So A prime is going to equal r times a. So a prime is going to equal r 6 times a, which is 7 comma 9. Now we're going to do the distributive property, so we're going to multiply this. So I'm going to show all my work, so I'm just going to do that on the first one. So a prime is going to equal the 6 times the x, which was 7, comma, and then we're going to multiply the 6 times the y, which is 9. So then I'm going to say 6 times the 9, which is y. So then finally, I'm going to get a prime to equal 7 times 6, which is 42, comma, 6 times 9 is 54. And so my dilated point of 7, 9, scaled up 6 by a scale factor of 6, is the point 42, comma, 54. Okay, so I'm going to continue in that fashion. I'll change colors here. So now I'm going to say I want to know what point B prime is. So I say B prime equals R times B. Okay, my R is a half this time, so these numbers are going to get smaller by a scale factor. When R is between 0 and 1, it's a dilation shrink. So B prime is going to be closer to the origin than the preimage B. All right, so the R is 1/2, and B is -8, comma 5. I'm going to distribute, and that is going to give me B prime equals 1/2 times, and I'm going to put these integers, -8 over 1, comma, another integer times a rational number is going to give me the rational number times the integer represented as a rational number, 5 over 1. And then finally, my B prime is going to equal, and there's some canceling that's going to go on here. 2 goes into 2 once. 2 goes into -8, -4 times. So it's 1 times -4, which is -4, over 1 times 1, which is 1. So it's -4, comma, and then 1 times 5 is 5, and 2 times 1 is 2. So that's 5/2, or 2 1/2. Okay, so those two numbers are less than this, closer to the origin. Okay, number 3. We want to know what the coordinates of point C prime are. So I'm going to write C prime equals the scale factor R times the preimage C. My scale factor is 3/4. So C prime is going to equal 3/4 times C, which is 6 -2. So it's like that. We are going to distribute the 3/4 times the 6 and the 3/4 times the -2. So C prime is going to equal the point 3 over 4 times 6 over 1, comma, 3 over 4 times -2 over 1. Do not forget that negative sign. All right, so now the last step is just simplify. 4 reduces to 2, 6 reduces to 3. 3 times 3 is 9 over 2. 9/2 is 4 1/2. And I'll write it as a mixed fraction. And this -2 becomes -1, and this 4 will become 2, so it's -3/2, or -1 1/2. So since r was less than 1, these numbers are smaller than our preimage. Okay. Okay, I paused there because that didn't look right to me. It's 3 halves, which is negative 1.5. So let me fix that. It is negative 1.5. Okay. Always question your work when you're done. If something doesn't seem right, check it. So there's the answer. 4.5 comma negative 1.5. Okay. Number 4. We're looking for point D prime. D prime equals the scale factor R times the preimage D. D prime equals scale factor R 4 times the point D, which is 0, comma 11. So scale factor 4, these numbers are going to get larger being further away from the origin. So I'm going to distribute. So D prime equals, and what I'm distributing is 4 times 0 and 4 times 11. And I'm just out of habit and going to show all of my work. 4 times 0, comma 4 times 11. And D prime is going to equal 4 times 0 is 0, and 4 times 11 is 44. So this number got larger. Now the 0 did not get larger, but the point did get further from the origin, even though the x did not change. And number 5, they want to know where E prime is. So E prime equals the scale factor times the preimage E. Scale factor is 3 halves. So E prime equals 3 halves times E, which is negative 2, comma negative 5. And I'm going to distribute. So I'm going to distribute 3 halves times the x and 3 halves times the y. And that will yield 3 over 2 times negative 2 over 1, comma 3 over 2, comma negative 5 over 1. Okay, so here the 2 is going to cancel with this, and that's going to become negative 1, and that's going to become 1. Okay, so my E prime is going to equal 3 times negative 1, which is negative 3 over 1, or simply negative 3. 3 times negative 5 is negative 15. 2 times 1 is 2. Negative 15 divided by 2 is negative 7 and 1/2. Okay, so this is my original point, my preimage. R is greater than 1. These numbers are further from the origin. Careful with how you word that. These are not larger, they're smaller, but since we were negative, we are getting further away on the left and below the origin. Okay, and here's number 6. So exercise 6 through 8 says the coordinates of triangle ABC are shown on the coordinate plane below. The triangle is dilated from the origin, so here's the origin right here, by a scale factor of r equals 12. Identify the coordinates of the dilated triangle A prime, B prime, C prime. Okay, I'm going to pause the video, see if you can do that, and we'll come back and check it. Okay, so the first thing we want to do in these types of problems is identify the locations of these points. So A is the point negative 2, comma 2. BE is at the point negative 1 or 3, negative 3, comma negative 3. And C is at the point 6, comma 1. So there are my 3 points. Our scale factor is 12. Identify the coordinates of the dilated triangle A prime, B prime, C prime. Okay, so here's what we're just going to do the same thing now. We want to find out what A prime is, and that is going to equal R times A. I'm just going to write the formulas first. We want to find where B prime is, and that is our scale factor times B. And we're going to find out where C prime is, which equals R times C. Okay. Now coming back to this. Now remember, R equals 12. I'll write this over here because I'm going to scroll a little and you're not going to be able to see it. So I'm going to scroll up. So my R is right here. It's 12. We're scaling larger. We're getting further from the origin. This triangle is going to be much bigger than this one here. It actually won't even fit on the screen. So A prime is going to equal 12 times my point A, which was negative 2, 2. So A prime equals 12 times negative 2. I'll put that in parentheses since it's negative, comma, 12 times 2. All right, so I just didn't show my arrows here. What we're doing is we're distributing the scale factor to x and to y. And my A prime is going to become a positive times a negative is negative. 12 times 2 is 24. And a positive times a positive is positive, and 12 times 2 again is 24. So my A prime is going to be negative 24, positive 24. It's going to be way up over here off the screen. Okay, B prime equals R times my B, which is negative 3, negative 3. Okay, I'm going to distribute, and I'm going to distribute. So I'm going to end up with B prime equal to the point 12 times negative 3, comma, 12 times negative 3. So B prime is going to equal negative 36, comma, negative 36. So B prime's way left 36, and then way down 36, way down here off the screen over here. Okay, and finally C prime. C prime equals R, which is 12, times the point C, which is 6, comma 1. And I'm going to multiply through, distribute the 12 into the x and the y point, and that's going to give me the point 12 times 6, comma 12 times 1. So C prime equals 72, comma 12. Okay, lesson 7 says figure DEFG, which is a quadrilateral, is shown on the coordinate plane below. The figure is dilated from the origin by a scale factor of 2/3. This one is going to be shrunk, so this one will fit on our screen. Identify the coordinates of the dilated figure D prime, E prime, F prime, G prime, and draw and label that figure on the coordinate plane. So this one they want us to draw and label. The other one was not possible to do. So the first thing I'm going to do, again, is label my points with their coordinates. And this is negative 6, comma 3. And G is at the point negative 3, comma 3. And F is at the point 5, comma negative 2. And E is at the point 4, comma negative 3. Okay. So again, my scale factor is R equals 2/3. I'll write that over here because I'm going to scroll a little bit. R equals 2/3. Let's bring this up to here. That's as much as we need. And here we go. So D prime is going to equal R times D. D prime, 2/3 times D, which is negative 6, comma 3. I'm going to distribute the scale factor through the x and the y. So I'm going to get 2 over 3 times negative 6 over 1, comma 2 over 3 times 3 over 1. So D prime is going to equal this 3 and this negative 6 will cancel, and that'll be a negative 2. So 2 times negative 2 is negative 4. And down here we have 1 times 1, so that's just an integer, negative 4, comma, 2 times 3 is 6. Actually, the 3's cancel, and I end up with 2 over 1. So the first point is negative 4, 2. So I'm going to graph that now. I'm going to go over negative 4, up 2, and here is D prime. Okay. G prime equals R times G. G prime equals 2/3 times negative 3, comma 3. I'm going to distribute the 2/3 through the x and the y. So G prime is going to equal the point 2/3 times 3 over 1, comma, 2 over 3 times 3 over 1. Okay, and that is a negative 3. Okay, so G prime equals, the 3's cancel, leaving negative 1. 2 times negative 1 is negative 2. And the 3's cancel over here, and we get positive 2. So G prime is negative 2, 2, which is right here. And that is G prime. Okay. F prime. Again, it doesn't matter what order we do this in. I'm going clockwise. They labeled it counterclockwise, but that's okay. So F prime equals R times F. F prime equals 2/3 times the point F, 5, negative 2. And I'm going to distribute. So it's 2 over 3 times 5 over 1, comma, 2 over 3 times negative 2 over 1. So F prime is going to equal 10/3, which is 3 and 1/3. And 2 times negative 2 is negative 4 over 3, or negative 1 and 1/3. So I'm going to go over 3 1/3 and down 1 1/3. So I'm about here. Okay? So I went over 3, and if I broke this up into thirds, 3 and 1/3 is about here. And if I come down, and that's 1/3, that's 2/3, that's 3/3. So I'm about right there, and I will call that F prime. Okay, just to give you an idea of how to do a point, approximate a point that's not an integer. Okay, and finally, let me not use blue. Finally, we're going to do E. E prime. Actually, I want to use a different color for each one, just so you can identify where they came from. E prime equals R times E. E prime equals, substitute 2/3 in for R, substitute the point in for E, 4, negative 3. And we're going to, again, distribute. Okay, and I did that here, by the way, and I didn't label it. Okay, E prime is therefore going to be the point 2/3 times 4 over 1, comma, 2/3 times negative 3 over 1, parentheses. E prime. 4 times 2 is 8, divided by 3. 3 goes into 8 twice, with a remainder of 2, so it's 2 2/3. And the 3's cancel, leaving 2 times negative 1, which is negative 2. So I'm going to go over from the origin 2 2/3, and then down 2. So I'm about here. And that will be E prime. No, it won't. I just realized that should be a negative 4, and therefore that is a negative 4, and therefore that is a negative 4, and therefore that is a negative 2 2/3. And once I put that, I realized that this would not be the same shape, and when we dilate, we preserve shapes of objects, or the angle measures would be preserved, and that would have changed the angles. So it's negative 2 2/3, comma, negative 2, which is here. And that's much better. Okay, so that's E prime. So now I'm going to get my ruler, and I'm going to draw my image. Connect those. Try to be as accurate as possible with this. Please do not draw these lines without a ruler. These should be pretty precise straight lines, segments. And there is my scaled B prime, E prime, F prime, G prime quadrilateral. Okay, last exercise, lesson 8. The triangle ABC has coordinates A, 3, 2, B, 12, 3, and C, 9, 12. Draw and label triangle ABC. So stop right there. A, 3, 2, 1, 2, 3, 1, 2, A is here. I don't like putting my letters until I'm done because I don't like my lines going through my labels. B is 12, 3, so that means go to the right 12, up 1, 2, 3, so that is here, that's B. And C is 9. Start at the origin, go over 9, and up to 12. So 9, 12 is right here. Now that I know where the triangle is, I put the label outside, and I'll put the value, the unit, or the coordinates next to it. So this is the point 3, comma 2, and that was A. And this is B, and it is 12, comma 3. Then I get my ruler out and precisely draw a triangle. Okay, so there's my triangle ABC. Okay, now it says the triangle is dilated from from the origin. So we're dilating from here by a scale factor of r equals a third. Identify the coordinates of the dilated angle triangle ABC, and then draw and label the triangle A prime, B prime, C prime. So r is 1/3. I'll write that over here. Okay. I think I'll use black this time. So I want A prime to equal r times A. B prime is going to equal r times B. And C prime is going to equal r times C. So A prime equals the scale factor, 1/3, times the point A, which is 3, 2. B prime is going to equal that same 1/3 by point B, which is 12, 3. Okay, this time I'm going to do this one step at a time for all three equations. And C prime is going to equal 1/3 times the point C, which is 9, comma 12. Okay, sometimes I like to do problems like this so that you just keep doing the same process repeatedly in each. Distribute, distribute, distribute. That will give us A prime equals 1/3 times 3 over 1, comma 1/3 times 2 over 1. B prime is going to equal 1/3 times 12 over 1, comma 1/3 times 3 over 1. And C prime is going to equal 1/3 times 9 over 1, comma 1/3 times 12 over 1. Okay, A prime is going to equal, the 3's cancel, we have 1 over 1, which is 1, and then we end up with 1 times 2, which is 2, and 3 times 1, which is 3. So A prime is at 1, comma 2/3. B prime, the 3 will make this 12 a 4, 1 times 4 is 4, denominator 1 times 1 is 1. So I will not write that as a fraction, let me just write that as 4. Okay, the 3's cancel, 1 over 1 is again 1, and then finally C prime is going to equal, 3 will make this 9 a 3, and 1 times 3 over 1 is just 3, and this 3 will make this 12 a 4, 1 times 4 over 1 is 4. So there's my new points. A prime is at the point 1, comma 2/3, which is approximately here, 2/3 of the way up. Okay, that is A prime. B prime is at the point 4, comma 1, which is here, and that's B prime. And C prime is at the point 3, comma 1, 2, 3, 4. Here is C prime. Now I'm going to get my ruler, and I shouldn't have to move it for the first drawing because what do we know about side or segment CB when it gets dilated? Everybody here? Anybody? Bueller? They are parallel. Okay. So C prime, B prime is going to be parallel to CB. C prime A prime is going to be parallel to CA. And finally, A prime B prime is going to be parallel to AB. Okay, there we go. So the red triangle is the pre-image, scaled down to the black triangle, which is the image. And we know it's smaller because the scale factors between 0 and 1. That is the end of lesson 6. Review the lesson summary and go do your problem set.